Okay, so we're recording. This is Projectile Motion Problem 2. And so we have a crazy, fun-loving little guy. He's throwing a ball horizontally from the top of a 45-meter high building. It's going to land 30 meters away from the building. So first, I'm going to write down a couple of things I already know about the ball. All right, let's see. So I know for sure this is going to be a question on the next test. The acceleration of the ball. Well, the acceleration of the ball once he throws it, it's 10 meters per second downward. Period. End of story. Anything released or thrown near the surface of the earth has the same acceleration. It's about 10 meters per second. That means the speed of this thing in the downward direction increases about 10 meters per second every second. Whether it's moving sideways or whether it's just dropped or whether it's thrown up in the air. The answer is 10 meters per second, which is the same as 10 meters per second squared. And it's directed downward. All right. So yeah, that question will show up again. This acceleration is about 10 meters per second. And then in the problem, what else here we want to know? We want to know, in this problem, what is delta y? That's the height of the building. So that delta y is 45 meters. It's a 45-meter high building. Ooh, you know what else? It lands 30 meters away from the building. That's horizontal distance. That's delta x. And then, well, we don't know how long it takes to land. And in this problem, we also don't know how fast this little guy threw it. What was this guy's initial velocity? That's going to be a question here, right? So what is V naught? So then to help me see this a little more clearly, I'm going to draw another picture here, right? Just like from the side view. So let's do this. Pictures not drawn to scale. All right. So here's your little ball. We've done this problem a few times. Not exactly the same as this, but just like it. So then we want to know what is V naught, okay? In the previous problem, we knew what V naught was, and we had to figure out what X was. This is just the reverse. Now we know what X is, but we don't know what V naught is. You work it out exactly the same way. So first of all, by kind of drawing everything that we need to know here, just to help us visualize things. So there's your delta y. It's 45 meters. So just seeing the delta y here is 45 meters, some of you are already going to know exactly how long it takes the ball to land. It's exactly the same time it would take if you just dropped it from rest from 45 meters above the ground. How long would that take to land, right? If I just let something fall straight down, bloop. And then the ball moves along a parabolic path through space. It's actually moving through space-time. How crazy is that? So that path is like this. And we know how far away it lands this time. That's delta x. So delta x here is 30 meters. So then, time. How long does it take to fall? We did this yesterday and last week and the week before that, but that's okay. So here we go. The equation we're going to use to find time here is this guy. Delta y is equal to 5t squared. So the delta y is 45 meters. All right, to get the t by itself, the first thing is divide both sides by 5. On the left, 45 divided by 5 is 9. 5 divided by 5 is 1. So I just have 9 is t squared. So now the question is, what number squared equals 9? So some of you might know this off the top of your heads. If not, algebraically, you take the square root of both sides. The square root of 9 is 3. Grab your calculators if you're not sure. So the time is 3 seconds. It's how long it takes to land. Regardless of how fast you threw it, or whether I dropped it, it's going to take, if it's horizontally launched or released from rest, it's always going to be 3 seconds if it's 45 meters. So now, we want to find V naught. This is just like finding X if we know V naught, but it's the reverse, right? The equation here is, how about X is V times T. In the horizontal direction, there's no acceleration. It's just distance is velocity times time. So the X is 30 meters is equal to V naught times 3 seconds. So 30 is question mark times 3. What number do you multiply 3 by to get 30? Some of you are going to say, oh, wait, let me think about that. It's 10. Yeah, 10 times 3 is 30. If you're not sure about that, that's okay. We can divide. You can do this algebraically. Divide both sides by 3 to get rid of the 3 here. Algebra to the rescue. So 30 divided by 3 is 10. And 3 divided by 3 is 1. So V naught is 10, and the dimensions are meters per second. So V naught here in this problem is 10 meters per second. And I think that answers everything. How about this? When the ball hits the ground, it's moving this way with the same V naught it had up here. It's 10 meters per second. How fast is it moving in the downward direction? What is Vy? Well, in the downward direction, it started off at rest. It was not moving down at all. It's gaining 10 meters per second downward every second it's falling. So in 3 seconds, well, that's 10, 20, 30. But it's moving 30 meters per second in the downward direction. The overall motion, of course, it's moving along a diagonal path, right, like this. And that turns out to be just the diagonal of this little rectangle here, with one side being 10, the other side being 30. So the overall speed is going to be a little more than 30 meters per second. In any case, so there you go. Problem done.